Here we're given what seems to be a very complicated problem. We're asked to find in the figure below, which is a square ABCD, given the points that are chosen along the perimeter, they form four congruent triangles, and they also form this square here on the inside. The question is, what fraction of polygon EFGH, what fraction of the big square is the little square? So, in other words, how much area does this take up relative to how much area the whole thing takes up? So because we know this square fits inside the bigger square, the answer has to be less than 1, right? It's a fraction of the overall space. Before I even get started then, I know I'm looking for a fraction. What I'm going to do is I'm going to eliminate anything that's got a fraction that's larger than 1. So you see, for example, G is 5/4. Well, that would mean that the area of the little square is bigger than the area of the big square, so that option is gone. Secondly, you see J is 9/5. Again, the little square can't be bigger than the big square, so that option is gone. And K is 12/5, so the little square can't be bigger than the big square, can't be larger than 1. So all three of those options are eliminated. So it really comes down to, is it 4/5 or 5/8? Now, to work on solving this problem, you need to look at what is known at this point. One of the things we see is that inside these little triangles, we're given the measure x for this side and 3x for this side. And because all of these triangles are congruent, we know that we would see over here, we would see this would also be an x, this would be a 3x, this would be an x, 3x, x, 3x. Because we know that, we see that the total measure of one of these sides is 4x. So the area of this larger square, the area of the big square, is going to equal 4x, that's the length, times the width, which is the exact same, another 4x. So the area of the big square is going to be 16x squared. Now, in order to find the measure of this side of the hypotenuse of these triangles, we can use Pythagorean theorem. And we can see that we have 3x plus x. 3x squared plus x squared equals, let's call this side c, c squared. Once we know that, we can multiply this out and get 9x squared plus x squared equals c squared. 9x squared plus x squared is 10x squared equals c squared. And so now we know then the measure of this side is 10x. If 10x squared equals c squared, then c by itself would just equal 10x. Now that we know that this side is 10x, and since we know it's a square, then all these sides also have to be 10x. Now we can find the area of this to be represented as 10x squared. So overall then, we have the area of the little square, EFGH, equals 10x squared. And the area of the big one, the area of ABCD, equals 16x squared. Now we're just simplifying 10x squared over 16x squared. These x squareds cancel each other out, and 10/16 can be reduced to 5/8. So the correct answer is H, 5/8.